First, what does scalability means? Imagine you have a lemonade stand. At first, you might have just few customers, but when it gets hot outside, many more want to have a lemonade. Scalability is all about how your stand can handle more customers. For example, a streaming service like Netflix needs to be scalable because millions of people watch movies and show at the same time. There are two types of scaling: horizontal scaling and vertical scaling. In horizontal scaling, you add more instances of your application as workload grows. For example, if an application initially handled 1000 requests per second with two instances and traffic double to 2000 requests, you can add more two instances to handle the load. This method is often more cost efficient, especially as compute resources have become cheaper. Here in this case, you are seeing one server and there are other servers. If workloads grows or request grows, you can add multi-mole server to handle those requests. The another example and op- another option is vertical scaling. Instead of adding new instances, you increase the power of single instance. For example, a database server can be upgraded with additional memory and CPU. However, this method can become expensive as hardware gets larger. An example: when the enterprise database required a larger server or more extensive data processing. As you can see here in a vertical scaling, initially you have a small server, but as your workload grows, you need to add more power to the server. So to the physical server, it's very difficult to add more power due to the limitation of its capacity. So normally in vertical scaling, you need to go for a bigger hardware. Let's talk about the capacity dilemma. Consider an e-commerce website. Throughout a year, it has a regular traffic, but during the events like Black Friday, traffic can spike. The challenge here is capacity planning. Ordering additional hardware for those peak period can take weeks or even months. Example: this is how the Amazon manage this. They use a cloud service that allow them to scale their infrastructure up and down based on their demand, ensuring they can handle the increased load during the peak shopping seasons without the overhead of ideal resources for the rest of the year. For example, you can see here in this picture the other day capacity is normal, but when there is any discounted or a Black Friday or any peak happen, so load increases. So that's how the normally elastic capacity dilemma is handled. Elasticity in three-tier architecture. In a typical three-tier architecture, you have a load balancer at the front, followed by web servers, application servers, and database. Elasticity is achieved using auto-scaling. For example, when traffic increases, the load balancer distributes requests across the multiple web server, and auto-scale adds the more and remove more servers based on the demand. If CPU utilization exceeds a certain threshold, says 50% or a 60%, the system can automatically provision additional instances. For example, here in this picture, if the load increases to the application server, so there will be a load balancer here. Load balancer handle the request based on the utilization of respective server CPU and memory. The additional CPU and additional server will be added or removed. That's how it is handled. Example of scalability is static content scaling with CDN. Web applications are more often heavy to on a static content like images and video. Storing this content on your website can be a latency issue. So, using a content delivery network like Amazon CloudFront can help. For example, a fashion retailer can cache image of product at edge locations worldwide, reducing load time for consumer accessing the sites from a different region. In this picture, you can see the application here at a central location somewhere. And whatever images, videos required have been stored to a certain repo, and edge location is enabled for those customers. So for example, customer from the world accessing this particular application, they will get content from their closest server, that is called edge location. That's how it is worked to reduce a load of a content from the certain application. One important aspect of scaling the application is managing user session. For example, for instance, if a customer is browsing a product on their mobile, either from Amazon or any e-commerce website, and later decides to purchase from their desktop, maintaining their session is crucial. By storing user session in NoSQL database like Amazon DynamoDB or MongoDB, the applications can scale without impacting the user experience. For example, if I want to buy something from Amazon, I logged into the Amazon web application. I found a product. I searched the product. That particular information and session store at Amazon NoSQL database. And when you go come back to home and try to browse the same stuff, you will get the same session. So it normally, provide a great user experience, and you know it if it is if traffic increases, the additional application instance can be added seamlessly. That's how it is used. And database scaling. So a relational database can become a bottleneck as they don't scale horizontally easy. A solution for this is using RAID replicas to distribute RAID queries. For instance, if a master database is handling a heavy write operation, setting up a RAID replicas can offload a read traffic. Amazon RDS allow you to create up to 6 RAID replicas for your database, improving performance without compromising any data integrity. Let's example, you have a traffic which is coming from an application, and the application has so many uh, read and write operations. So you can segregate those operations. So write operation can happen on particular database, read application happen on replicas, and you can create more replicas where read operation can happen. But in this diagram, database vertical scaling is vertically. So database scaling is happening vertically. So initially it was 4 CPU, 8 CPU, and 32 CPU. Accordingly, the RAM and hard disk increase. That's how the database scaling work. Scalability and elasticity are key component of solution architecture. By leveraging tools like load balancer, auto scaling group, CDN, and database replication, you can build robust system capable of handling various workload efficiently. In the next video, we shall dive into high availability and resiliency. So make sure to subscribe and hit the notification bell to stay updated. Thanks for watching, and I'll see you next time.